So let's start drawing some structures. Now the structures that I'm referring to are called Lewis dot structures, and I want to focus primarily here on ionic compounds. So once you define the type of bond that exists on your molecule, and you say that, hey, it's ionic, then this is what you would actually do. So we want to start off by writing the element symbol, and then the reason that this is called a Lewis dot structure is because the electrons are actually pictured as dots around the outside of the symbol. Now, each symbol has a maximum of what you would call four sides: the top, the bottom, the left, and the right. The second rule is that you can have a maximum of 2 dots per side. So we would first write out the element symbol for sodium and then draw 1 dot around the outside, since it's part of the alkali metals and only has 1 valence electron. Now, unfortunately, because this is an ionic compound, it's not just Na that's involved in this bond, it's really sodium ion. Now, sodium ion is a 1+ charge, and it gets that 1+ charge by losing an electron. So we need to draw that a little carefully. So we'd basically erase the dot and then show the charge. And that looks like this. So we'd write down Na with no dots around the outside, a pair of square brackets, and then a 1+ charge up in the top corner. The square brackets around the Na symbol indicate that we've modified the Lewis dot structure from its 0 charge state. Let's do chlorine now. Chlorine has 7 valence electrons, so we draw in 7 dots, 3 sets of pairs, and then 1 lone dot. It doesn't matter what side that lone dot shows up on, as long as there's 1 lone dot around that structure. And again, because it's an ionic bond, it's not chlorine that's involved in this, it's chloride ion. And chloride ion has a -1 charge. You get a -1 charge by gaining an electron. So we need to draw in an extra dot, and then show that we've modified it by adding in an electron. And that looks like this. So chlorine is now pictured with 8 dots around the outside, a set of square brackets to indicate that we've modified the structure, and a negative charge on the outside to say, hey, we've added an electron. So now we need to marry together these two images into NaCl's complete picture. And that's exactly what it looks like. Let's try another example of an ionic compound. How about CaCl2? Well, let's go through the process again. We first write out the Lewis dot structure for calcium. Calcium has 2 valence electrons, so I draw in the 2 dots. Now notice this time how that was done. Another rule of drawing a Lewis dot structure is that you need to draw 1 electron on each side of the atom until you have to double up, essentially following Hund's rule. Now, calcium inside of calcium chloride, since it's an ionic bond, doesn't exist as calcium, it's calcium ion. That's Ca2+. It becomes Ca2+ by losing 2 electrons. So we're going to draw square brackets around the outside, erase the 2 dots, and indicate a 2 positive charge. Go through the same process with chlorine again. Here's chlorine with its 7 dots. We modify it to chloride ion by gaining an electron. 8 dots now with a -1 charge. And now we go to draw its final structure. So we draw 1 calcium and 2 of these chloride ions around it. And your final structure would look a little something like this.